Welcome to this explainer. Today, we are going to completely deconstruct the universe-altering genius of Sir Isaac Newton. We're going to map out exactly how one man fundamentally rewired humanity's entire understanding of light, motion, and the cosmos itself. Now, to truly grasp the sheer magnitude of his work, we really have to ask ourselves, how did one 23-year-old in quarantine permanently change our understanding of the universe? The year was 1665. The Great Plague was ravaging England, which forced Cambridge University to close its doors. So a young Newton retreated to his family home, Woolsthorpe Manor in Lincolnshire. Far away from the academic elite, in total isolation, he was about to experience what he later called the prime of his age for invention.
Okay, let's dive straight into this. We're going to cover four main pillars today: his miraculous year of wonders, his grand unification of Earth and the heavens, the incredibly bitter calculus controversy, and finally, his surprising third act as master of the Royal Mint.
Part 1. The Year of Wonders and Unlocking the Secrets of Light.
So before Newton came along, pretty much the entire scientific community believed that a glass prism actually altered white light to create colors. But Newton engineered a brilliantly simple sequence of steps to test this. He darkened his room, let in just a single, narrow beam of sunlight through a tiny hole in the window shutters, and passed it through a prism to create a spectrum of colors. Then came the absolute genius move. He used a board with a hole in it to block out every single color except for one. Let's just say red. He passed only that red light through a second prism. Now, if the prism was what actually created the color, it should have changed that red light. But it didn't. The light emerged from the second prism bent, sure, but it was still totally red. This led him to a massive realization. Light consists of rays differently refrangible, original and connate properties. Basically, this was a radical paradigm shift in physics. It meant that sunlight was not some pure elemental substance. It was compound. All those different colors were already inherent in the white light, and the prism merely separated them out, because different colors bend or refract at slightly different angles. Honestly, that alone would secure a scientist's legacy forever. But let's move right into part 2, unifying Earth and heavens through gravity and mechanics. To understand why his 1687 masterwork, the Principia, absolutely shattered the scientific world, we have to look at the pre-Newton view. This was deeply rooted in old Aristotelian philosophy, and it held this strict, rigid conceptual divide. The heavens were considered this ideal realm governed by mathematical perfection, right? While the earthly realm was entirely separate, governed by its own flawed, imperfect rules. So an apple fell because it was just in its nature to return to the earth. But the Newtonian view completely dismantled this. Newton proved that the exact same universal physical laws govern both terrestrial bodies, like a falling apple, and celestial bodies, like the moon orbiting the Earth. He codified this in his Law of Universal Gravitation. Every particle attracts every other particle with a force proportional to their masses and inversely proportional to the square of their distance. This one single mathematical formula literally bridged the work of Galileo down on Earth and Kepler up in the heavens. It erased the conceptual divide in the universe. And this idea that physical laws apply uniformly everywhere no matter where you are is literally the foundational paradigm of modern physics today. And to model these kinds of forces, you need incredible, mind-boggling precision. Consider the number 6.674 times 10 to the negative 11th power. This is the gravitational constant, represented by a capital G in modern physics. Now, Newton didn't actually calculate this exact constant himself. He usually spoke in terms of proportions. But his equations lay the absolute framework that requires this incredibly minute, exacting scale to accurately model the gravitational pull between massive planetary bodies. But there was a glaring mystery left entirely unsolved. In the second edition of the Principia, Newton wrote, hypotheses non fingo, which translates to, I feign no hypotheses. So the crucial point here is this. Newton calculated exactly how gravity behaved mathematically, but he openly, frankly admitted he had absolutely no idea what actually caused this unseen force to act across the vast, empty void of space. To his critics, an invisible force pulling objects together sounded uncomfortably like magic. Yet, his math was undeniably perfectly accurate. All right, part 3, the great calculus controversy. We are pivoting now from cosmic unification to some intense, bitter human drama between Newton and the German mathematician Gottfried Wilhelm Leibniz. You see, to mathematically prove his theories of motion, Newton needed a brand new type of math, what we now call calculus. But the timeline of who invented it was incredibly messy. Newton began his method of fluxions back in 1666, but he kept it largely a secret. 8 years later, in 1674, Leibniz starts developing his own variant of calculus. And in 1684, Leibniz went to print first, publishing his method for the world to see. Newton didn't fully publish his own notation until decades later, in 1704. So Newton definitely did the work first, but Leibniz got to the printing press first. Now, what's really interesting here is when you compare their actual notations, the difference is striking. Newton used what he called fluxions, where he imagined quantities literally flowing through time, and he usually represented differentiation with a little dot over a letter. Leibniz, however, used the incredibly elegant dy dx for differentiation, and that big elongated S symbol for integration. If you've ever taken a calculus class, you will immediately recognize Leibniz's notation. While both men independently invented calculus, it is Leibniz's highly intuitive system of symbols that the entire globe still uses today.
They really just approached the math differently. Newton was trying to bridge physical observation with his fluxions, while Leibniz approached it more theoretically through summing infinite series. Today, the modern consensus among historians is absolutely clear. They invented it entirely independently of one another. But Newton was highly covetous of his work and incredibly sensitive to criticism. Driven by intense intellectual pride, Newton actually abused his power as president of the Royal Society to publish anonymous slanders, ruthlessly trying to discredit Leibniz and permanently staining their relationship.
Which brings us to part 4, Master of the Royal Mint. This is the final and perhaps most surprising chapter of his entire life.
You would probably assume that the guy who decoded the universe spent his twilight years just staring peacefully through telescopes, right? Well, actually, in 1696, Newton completely stepped away from the quiet academic bubble of Cambridge. He moved to London to become the warden and later the master of the Royal Mint. He took the exact same obsessive, relentless focus that he applied to planetary orbits and pointed it directly at the British economy. On his administrative crusade was fiercely effective. He spearheaded this massive project to recall and remint Britain's entire coinage system to stabilize their currency. But more than that, and this is wild, he personally and rigorously pursued counterfeiters. Back then, counterfeiting was literally high treason, and Newton acted almost like a gritty detective. He established a whole network of informants and relentlessly prosecuting criminals. For his lifetime of achievements across science and the state, Queen Anne knighted him in 1705, and he continued serving as president of the Royal Society until he died in 1727.
So, that leaves us with a genuinely provocative question. Did the man who decoded the universe actually find his greatest satisfaction in chasing down counterfeiters? It really forces us to reconsider Sir Isaac Newton, not just as a name on a dusty physics textbook, but as a deeply complex, multifaceted human being. A guy who was just as merciless in hunting down criminals in the dark alleys of London as he was in hunting down the mathematical truths of the cosmos. Something to chew on as you reflect on the incredible legacy we've unpacked today.